Okay, so just before I'll just wait. Thank you. So, just a moment ago, we talked about the strength of an association, and we said that the strength could be either strong, moderate, or weak. Yep, or none. Thank you. So, the problem with that approach, when we talked about how tightly or loosely clustered the data was around a straight line, was that that judgment was subjective. Wouldn't it be nice if we could calculate a number that could do that for us? And we can. We did this last year. So R is only going to be calculated using your CAS calculator. Okay? If you like, I can show you how to do it without the calculator. But it ain't pretty to look at. So I'll definitely show you later. Okay. So I do need to show you. So please get out your CAS calculators. Okay, we're good? All right. So please create a new document. Whoa, new document. Yes. All right. So if you like, we're gonna do question 3 from 2F. So Jason, wrong answer, buddy. 2F, question 3. We're gonna enter the data in from that. Okay. So you want to go to listen spreadsheet, and we've got 2 variables. So the first variable is maximum. And the second variable is called minimum. We're talking about temperatures here. So guys, remember, we have a scatter plot. So you're always going to have 2 columns of data. You have 1 column for X, 1 column for Y. So go ahead and chuck in the data. You don't need to graph it today. So just stay in the spreadsheet.
A, B, or C?
We're doing A. Fine. Hi. Yeah. Sorry. All right. Who's got the data in? Yeah. All right. All right, year 12s, please quieten down and follow my instructions. So if you weren't in not in methods, if you weren't in general last year, you need to memorize this. Cooper, time. Okay, menu. Number 4, statistics. Number 1, stat calculations. And this time we are going to do number 4, linear regression A plus BX. And you need to specify the variables. So at the moment it doesn't matter. We don't really care what the minimum or maximum is. I mean the EV and RV because we'll get the same R value. So just go ahead and put in the name that you had. And then press enter. And if you've done this correctly, you should get some statistics coming out on the right. I want to draw your attention to this one, this value called R. This is called the correlation coefficient. 0.818, yes. So once you round it, we are going to use this number relentlessly for the next few weeks. And this is a measure of how strong the association is. So let me tell you a bit more about this number now. Because now you know how to calculate it, now we'll interpret it. So the first thing you need to know about R is the following. R, I'm just going to pull it up. Hopefully it's faster now. Yes. R is always between, yes, you should write this down. Negative 1 and 1, very good. Okay. So, I think the easiest case to start off with is 1 and negative 1. Can anyone from my class last year tell me what it means when R equals 1?
It means that very close to the most.
Okay, you guys are almost there. The data is perfectly modeled by a line with positive slope. If you've come from methods, for whatever reason, VCAR uses the word slope instead of gradient in this class. So wherever you see the word slope, just think gradient. On the exam, they'll use the word slope. I wish they just used gradient. It'd be less confusing for everyone. Okay, the second case is negative 1. This time, instead of a positive gradient, it's a negative gradient. So I'm just going to abbreviate this sentence. Perfectly modeled with negative gradient. Sentence fragment is a sentence fragment. Okay, so these are what I might call the two extremes. R equals 1 and R equals minus 1. Everything that we will do in this class is going to be somewhere in between these two extremes, but you still need to know what 1 and negative 1 mean. Okay, third case. No association if R equals 0. So it's very hard to draw completely random data, but I'm going to try. I'm not exactly sure which straight line to fit to that data. If you were to go further, we would say there's no advantage to using the mean, a straight line, over a line with a gradient. Okay, now the moment that you've been waiting for. We're back to these terms now. Strong, moderate, and weak. So I need to say one more thing. So if R is greater than 0, the association is positive. If R is less than 0, the association is negative. So you need to know that. When I use these alligator symbols, you know what that means? Greater than, less than? Yes? I better write it just in case. Greater than, less than. Okay. So, I need to make sure I get the values exactly right. So this is something that will be used in your reference. Where is it? So I have a word example. Where's it? What? Oh, here we go. Page 143. So on page 143, you have a table. So we're going to say between 0.5. So they actually include 1, which is a bit confusing. This isn't the same as last year. Okay, I'm just a little bit wary of using these symbols. Do you know what these symbols mean?
Yeah.
Okay, so if you're a bit confused by this, please let me know. It sounds like most of you know what these mean. So when you have a line underneath, that means or equal to. When you don't have the line, you don't count the value. So if the size of R is between 0.75, not including 0.75, and 1, including 1, we're going to call that strong. If R is between 0.5 and 0.75, or negative 0.75 and negative 0.5, we're going to call that moderate. If it's between 0.25 and 0.5, or negative 0.5 and negative 0.25, we're going to call that weak. And add one more category, please. If it's between negative 0.25 and 0.25, it's none. So when you do your SAT, I will expect you to use the value of R to determine whether it's strong or moderate. Because you'll have the raw data, you won't be looking at a scatter plot without the actual values. Same with your exam as well, for the most part. Okay, so you need to use the value of R. Unless you've just been given a graph, you should use the value of R to determine the strength of the association. So the closer you are to 1 or negative 1, the more tightly the data is going to be around the straight line. Hopefully I can do some demos in a few weeks' time that you can play with. Okay, you guys all right? So here's the summary. Fit a straight line to data, and out comes this statistic called R, called the correlation coefficient. And we will use that to decide whether the association is strong, moderate, weak, or none. It's a recipe that you can just follow. You just have to follow the steps. So when you do 2F, you'll spend most of your time entering data into the calculator. And I think you can scratch question 2 from the word program. So I'll do question 2. Yes. All right, I'll stop recording and just show you why I'm telling you not to do question 2. Yes.